start somewhere in this life. Nobody knows ones and zeros, picking up the pieces to make things right. Oh, the challenge is great. Oh, trying to keep the faith. Remember, you've got the power to bring beauty back. Bring beauty back. Remember, you've got the power to bring beauty back. Bring beauty back. Oh, bring beauty back. Nobody knows ones and zeros. Oh, bring beauty back. Nobody knows ones and zeros.
All right, well, welcome to Clean Code in the Browser, Episode 4, the Liskov Substitution Principle. Last episode, what did we do? Let me check my notes here. Oh, that's right.
First, we talked about using our best practices both in thick and thin, falling back to our trusted process when times get tough.
Well, for all of the production outages that you've caused, that's some very good advice.
We discussed the problem of lone wolves, how they can appear to be top performers, while in reality, they undermine a team's ability to sustainably build quality software.
Hey, you look pretty good with that wolf mask on. Quite an improvement.
We then explored the open-closed principle. We learned how the technique reduces churn in our code by keeping it modular, making dependency interfaces explicit, and focusing on extension over modification.
Ugh, my arms are getting tired. Let's just get on to the new stuff.
So now is the time to look at the L in Solid, the Liskov Substitution Principle. Now this one is tricky in browser code because it has to do with base classes and subclasses and the relationships between them. So what if you're writing browser code but you're not using ES6 classes or TypeScript? If that's the case, what does Liskov Substitution Principle have to say to us? Is there a way that we can apply that principle to all of front-end JavaScript code? So we're going to talk about all of this and more, but first, what is that sound? Let's go check it out.
Crikey! Here we are in the wild, looking for the nesting place of these elusive creatures. It's very rare to find them in their natural habitat.
Oh my god, I was right. He is trying to be Steve Irwin.
Blimey, you can see him just over there in the clearing, fit as a malleable and playing like a berry. The drum circle.
Have you ever been part of a drum circle before? They were popular back in corporate America in the 90s as a team building exercise, and frankly, they've probably gone downhill since then. It's a shame, really, because there are some genuinely interesting lessons that we can learn from them.
To run a drum circle, the first thing you need is people. But not just any people, mind you. People who know each other, who solve problems together, and who have no idea how to play the drums.
Wait, what? I think there's been a mistake of some kind. I don't know what to do with this.
Perfect. You'll do great.
Wait, what? The foundation of the drum circle is the heartbeat, which is provided by the person who has the bass drum. Now, the great thing about the bass drum is you don't need to know anything about how to play it. All you have to do is hit it. Louder! Since no one in the group has ever played the drums before, usually everyone starts very timidly. I mean, no one wants to be the person who accidentally breaks their drum. Of course, then you remember that these drums were built to be beaten. Now that the heartbeat has established the tempo and the pulse for the rest of the group, it's time for someone else to summon their courage and create a simple but strong contribution. Now this drummer is only adding a couple notes, but they're playing those notes with fortitude. There is plenty of room left for others to join in, and the confidence is inspiring. This is pretty remarkable. We have a group of coworkers who don't play the drums and might not even be musical at all, and yet they've created a pretty nice groove. Each one of them is only playing a note here and a note there, but when you combine all the parts together, it creates a pretty compelling whole. And this works great, at least for a while. As the group continues to play, they get to feel a little more comfortable with each other and with the instrument that each of them is playing. It doesn't feel quite as foreign, doesn't feel quite as clumsy, and they're not quite as timid as they were when they started. A period of experimentation and diversion begins.
Their focus was initially outside of themselves, listening to the group and searching for a way to fit into the groove. Now, that focus has moved inside themselves, focused on their part, their performance, their contribution. You can visibly see the change in their body language. Rather than looking to each other, they have their heads buried in their drums, oblivious to what is musically happening around them.
At this point, the groove has been totally lost, and what we are left with is complete chaos. The music doesn't make any sense. None of the contributions are lining up to create music that is greater than the sum of its pounding parts.
It doesn't take long for our drummers to sense the chaos. It feels shocking, and it gets their attention. Reflexively, they simplify what they are doing, moving their attention back to the group. They start listening to the group again, intuiting the role they can play to help bring order to the chaos.
Great Scott! Are you seeing what I'm seeing? Great Scott! Are you Steve Irwin or Doc Brown? You billy-lid blobhead. The population has re-established equilibrium in its natural habitat.
Yes, they have. Without any kind of centralized leadership or musical talent whatsoever, this group wandered into chaos and then was able to retreat back to simplicity. The interesting thing is this doesn't just happen once, it's iterative. The group will oscillate from simplicity into chaos, into known safety, into the great unknown, and around it goes. But don't be fooled. The group is not regressing back to square one. They're continuing to move forward through exploration. Now think about the complexity of this situation. It's actually kind of hard to miss because there's not really anything at stake. So, let's up the ante. Hey! If you can create beautiful, meaningful music in the next 10 minutes, I will give each of you a huge bonus. But if you can't make beautiful music in the next 10 minutes, you are all fired. Well, now the stakes are high, and the situation is very complex. They've been given a very subjective mission of creating beautiful and meaningful music. They lack the domain expertise to know how to actually execute against this, and time is short. So how do they work through all of this complexity and come out with a successful outcome? Well, let's pause this for a moment, and we'll compare this situation to a different musical ensemble. The orchestra. Now, the charter of an orchestra is not far off from that of a drum circle. Create beautiful, meaningful music with as little preparation and cost as possible. The difference is in the constraints. An orchestra has skilled musicians who have mastery over their instruments. It has a conductor, and perhaps most importantly, written sheet music. A documented specification, if you will. This makes a huge difference. The musicians know exactly what they're supposed to play, and the conductor can help keep tempo and coordinate the musicians to ensure that everyone stays together. The orchestra benefits from a level of clarity and direction that the drum circle just simply doesn't have. The orchestra is focused on execution, while the drum circle is focused on exploration. So, how do we compare these two different challenges? Do we use the same techniques to solve them both, or are there different ways of approaching the problem? Well, we're able to use the Cynefin framework to answer these questions. So back in 1999, Dr. David Snowden first started working on the Cynefin framework while working for IBM Global Services. No, that's the wrong Snowden. There we go, much better. Snowden set out to create an organizational model that would help to explain different problem domains. Why was it that some problems were easily solved using best practices while others were not? And why was it that something like waterfall worked very effectively for certain problem domains while it utterly failed for others? The resulting Cynefin model is a useful tool for classifying problems and determining what the best techniques are for that class of problems. Now, they're broken up by level of complexity. Well, here, let me show you. Snowden identified 4 different problem domains. And the problems that fit into each are very distinct from one another, and the effective strategies are just as different. The first problem domain is obvious problems. These are known problems with known solutions. So all you really need to do is classify the problems and then apply the best practices.
Ha ha! You've tripped up now, Powers. Ha ha! Caught you red-handed. You said that we should never talk about best practices. We should be calling them leading practices instead. Ha!
Not quite. Leading practices like test-driven development or solid principles, these are for complicated situations where nuance and expertise is required to apply them correctly. Now, these problems that we're talking about are, they're obvious, and they literally have known best practices.
Oh no! Foiled again by logic. Curse you, Powers! Smoke bomb!
Continuing on, the next problem domain is for complicated problems. These are the problems that have many moving parts. They require highly skilled workers, they require coordination across groups, and perhaps some specialized equipment. Putting a man on the moon falls into this category. You know that your problem is complicated if it's clearly not obvious, but you do know where you are, called point A, and you know where you're headed, it'll be point B. Now, it might be difficult to draw a line between these two, but it's possible. For complicated problems, once you have the plan in place, then it's all about execution. A successful execution will deterministically give you a successful outcome, and a failed execution will deterministically give you a failed outcome.
Yeah, this is a very complicated problem. And check.
Well, it's pretty obvious on this side of the table.
Checkmate. No! I will not lose! Smoke bomb! What? Why are you... I can still see you!
Now let's compare that to the next problem domain, complex problems. Now these problems do not have deterministic outputs because they don't have deterministic inputs. Oh sure, you can do the research, you can create a project plan, you could execute it flawlessly, and then you realize that the target changed, or the market shifted, or your customer didn't actually know what it was that they needed. All that work, and what do you have to show for it? This is where best practices are completely inapplicable. Instead, we expect to find emergent practices through experimentation and through innovation. We anticipate learning along the way. While we're doing the work, that's when we actually discover the work that needs to be done.
Well, this is depressing. And I ran out of smoke bombs. Hashtag sadness.
Finally, the last domain is chaos. You do not want to be here. In chaos, you don't know where you are, you don't know where you're going, what the environment is. It's a complete mess. The only thing that has a chance in chaos are novel practices. Just do whatever it takes to get out and clarify the situation. Now, this is a very quick overview of the Cynefin framework, but it does give us some shared vocabulary that we can work with. Now, let's go back to our musical ensembles and apply some of these ideas about complexity to those situations. Performing a piece of music with an orchestra is a complicated challenge. It requires skilled workers, strong coordination leadership, and precise execution. Thankfully, the plan, the written notated music, gives us a very clear understanding of the intended end state. Given correct execution, we can expect to have a deterministic, positive outcome. This drum circle situation is not complicated, it's complex. We have no idea what we're doing with these things. We don't have the skills that we need in order to make a decent plan to move forward. The task that we've been given to do is totally subjective. Make good music? What does that even mean? I mean, we could put on a flawless performance, but if the customer didn't like the style or didn't like the sound, then it would be a failure regardless. We have an abstract idea of what we need to do, but we need to continue to explore and discover to find the path that will get us there. And that's not one and done. This is a continual iterative process. That's it. I have had it with this stupid shaker. You guys told me that this time I could have a drum, and yet here we are in Shakertown, USA. I quit. I'm done. La cucaracha, la cucaracha. Now, in software development, we spend the vast majority of our times up here in complicated and complex problems. We rarely spend time solving obvious problems because when we run into them, we usually just automate the solution. And we try to stay far away from chaos whenever possible. Spend too much time there and people just quit. At first blush, the differences between complicated and complex programming tasks may seem subtle. In the same way that someone could see very little difference between the orchestra and the drum circle, it's easy for software development tasks to be overgeneralized and miscategorized.
There are some familiar problems that may very well only be complicated. CRUD apps, ETLs, maybe some data analysis. If the team truly understands the requirements and the use cases, then it's possible that execution is the only thing that's getting in the way. While leaping lizards, you gotta watch out! Much of our work looks tame on the outside, but it's a real beast under the shell. That run-of-the-mill CRUD app or ETL still requires exploration and iteration in order to discover the secret use cases of your users. You do realize that's a terrible accent, don't you? Ah, too right, mate. She'll be apples, but I'm a dag drongo. Let's hit the tubs and tuck a bag.
Like the drum circle, our software projects tend to have vague, high-level requirements that are difficult to validate without just building it and testing it out. And we could build working software that meets every single one of those requirements and then realize that we have something that no one wants to use. Complex problems have non-deterministic outcomes. And this can be soul-crushing to see when a project fails just because a domain changed. But there can also be some benefits. Complex problems give us opportunities to get huge wins, maybe even with very small amounts of work. Still, as software developers, we feel much more comfortable working on the complicated problems. We are skilled workers, and we're used to lining our ducks up in rows and coordinating across a group in order to ship a successful release. That determinism gives us a sense of control. And this is where the appeal of Scrum first came from. Scrum gives us a process for engaging with large, complex projects, peeling off iteration-sized chunks, and then working on each of those iterations as complicated problems. The stories in our sprints have very clear acceptance criteria and very little ambiguity. It's easy to tell whether or not a sprint was completed successfully. We come out with a deliverable, with some new learning, and with a clearer path forwards. The danger, though, is that there's no guarantee that each of these extracted, complicated problems are going to move the needle on the big, complex problem. The sum of all of the parts does not deterministically give us a successful whole.
Wait, I must have misheard you. I think what you were trying to say is that Scrum guarantees successful outcomes because it's Scrum, Agile. Agile means faster and better, or your money back, okay? Well, for the rest of us, dealing with these complex challenges is still very difficult, even with a system like Scrum. The good news is there are some very concrete things that we can do to improve our chances. When you're dealing with a complex problem, you should expect to be learning along the way and apply those learnings to change your course. Don't rely on centralized leadership to solve the problems. It's way too slow. The more experiments that you run, the better your chances are of discovering a viable solution. Everyone on your team should be able to form a hypothesis and then execute against it. Wait, I must have misheard you again. I think you meant to say that I am a critical decision maker whose guidance and engagement is desired and required throughout the entire project, okay?
Now, before a line of code is written, we should be working with our product managers in order to validate the product ideas with real users. A little bit of prototyping can go a really long ways in verifying whether this is a viable solution or a total dud. Check.
Well, knowing how bad your ideas are, you may never have to actually write a lick of code anyways. Ha ha!
And just like a dingo coming back from the billabong, you've got to mitigate risk of exploration by working in small increments and getting fast feedback loops. Well, that is true. It's the only way to know whether your work is actually satisfying the needs of your users. The longer you go without shipping, it's like the longer that you're swimming without a life preserver in a billabong. So validate your assumptions. Assume you will learn things along the way. Work in short iterations with fast feedback. Make sure that the people doing the work are the ones making the decisions. And if you go to a drum circle and they hand you a shaker, you just take that shaker and you throw it right back in their face, because that is some serious bullshit. Cut. Okay, oh, that's a wrap, everybody. Good job.
No paint? No paint! Oh, no paint! Oh, my inspiration lost! Why have you betrayed me? Oh, no! Well, there is one redeeming piece of this situation, and that's that I have purchased a wonderful software solution to keep track of these pigmentationless travesties so that they may never happen again. Let's open it up. So, how do I open the app? Oh, maybe they have instructions on their website. I'll go take a visit. Here we go. FAQs. How do I convert from RGB to CMYK? Well, no, I need to open the app first. How do I support multiple users on one account? Well, that's a good question if you have multiple users who would all like to not open the application. Why does the app crash when I log 1,000 paints at once? Honey, you ought to be glad that you got the application to open in the first place. For goodness, here it says, I love this app so much, how do I upgrade to premium? Well, I would upgrade to premium if it would just let me open the application. Can I purchase this software with Bitcoin? That's it. F you, FAQ! I'm calling your manager. Customer service.
Hello, and thank you for calling customer support for the Painttastic 2000. How may we surprise and delight you today?
Oh yes, wonderful, a real person.
Well, you see, what I need is...
Oh, and before we get too far into it, have you read the FAQ on our website? We find that most of our customers find the answers that they need in the FAQ.
Yes. Yes, I
read the FAQs. They were like throwing a drowning man an anchor.
Oh, of course. Now, first, let's do a quick check. Is your device plugged into the wall?
Well, no, it's not plugged into the wall. The device is working fine. I just need to open the app.
Yeah, well, what I think I'm hearing you say is that the user experience may not be meeting your expectations. Is that right?
Well, my expectation
is for the damn app to open. So no, it is not meeting my expectations.
Yeah, that sounds like UX feedback. Please hold while I transfer you to the UX department. Thanks.
Oh, no, wait, I just...
Hello?
This is the user experience office, where your experience is our expertise. How may I help you?
I just can't open the app.
That's it. I just don't know how to open it.
Oh, well, this is an easy one. I know just what to do.
Oh,
I'm so glad. Here I thought you were just going to transfer me off to the next department.
Yep, this is clearly a software issue, so I'm going to transfer you over to engineering. Please hold. Hello, and thank you for calling customer support.
The app does not open! open or you will pay! Pay!
Whoa, okay, now hold on. We will definitely help you with your problem. Hey, Marty! Tell security to lock the doors! We got another one! Okay, let's take this step by step. So first, open up your terminal app or PowerShell. Once you are at the command line prompt, type PAINTJS and hit enter.
Terminal? PowerShell? I don't think I've got any of that stuff on this iPad.
Oh, an iPad. Oh, no. I'm sorry. We don't support the iPad. This is desktop software only. It's an MVP after all.
What do you mean you don't support my iPad? I'm giving you $1,500 a month for an enterprise support package.
Oh, well, sure, but most enterprises haven't really started using tablet devices yet, so...
You will solve my problem, and you will solve it now! Good day, sir! I said good day!
Well, looks like it's time for me to do my job and tell someone else to do some work. Yeah, hi. We've got a bit of a situation here. We have a very angry customer who is threatening us all with bodily harm, and worse, threatening to reduce our annual recurring revenue numbers. Yeah, I'm gonna need you to work this weekend on a web UI for our Paint.js software. Maybe you can use one of those neat Web 2.0 Ajax things that I've been hearing about lately. Yeah, so I'm gonna need it ready by Monday, okay? Thanks.
There's something strangely familiar about this situation.
Well, this might be a good chance for me to build something in React. We'll probably knock it out pretty quickly. Plus, there's a good chance that the Facebook lawyers won't sue me for using it. Neat! Now, before we start, this is not meant to be a React tutorial. And in fact, we're not even going to be doing anything that's particularly interesting with React. You can easily sub in your own view layer of choice, and all the ideas still make sense. So I've already bootstrapped a React application using the Create React App library, which is a pretty handy tool for getting started. Now I've put in some preliminary markup and styles, but the app doesn't do anything yet. So let's take a look.
So we start things off with some React boilerplate. We are creating our first component, which I'm just calling app. An app is going to render out our entire view. So every React component has a render function, and the job of that render function is to spit out a bunch of markup. Now, if you're not familiar with React and with JSX, this may look very, very strange to you. We just have a bunch of HTML strangely thrown in with our JavaScript code. Now, we use preprocessor tricks to basically turn all of this HTML into proper JavaScript statements, which frankly I'm glad I don't have to write out by hand because it's a real drag. So this is a nice shorthand. Now there is a username field. There is a quantity field, say how much paint have you used. We have a multi-select that allows you to choose which are the colors of paint that I've used. Now, no form would be complete without an option to join the mailing list. So, of course, we have to have a checkbox to join the mailing list, a submit button. And then the last thing that we have here is going to be a text area that I just want to use for a feedback cycle. I want to be able to inspect what the state, the internal state of this component is. And so we're actually binding the value of this text area to this .state JSON function, which is defined up here. All we're doing is we're JSON stringifying the state of this component. Now, right now, the component has no state, but we'll be changing that as we wire this up. Taking a look in the browser, I know, it's beautiful, isn't it? Some simple styling, but you get the idea. We have that username field, we have the numeric quantity field, you're able to choose many colors, join the mailing list, and at some point, this box here will be showing us the internal state of our component.
Now, as you can see, nothing's wired up yet. As data is entered, we'd like to update the state of the component and then use a post request to send that data up to the server. Now, for our purposes here, submitting the form is just going to print out the data to the screen. Let's wire that up first.
So we already have the state JSON function that is going to stringify whatever the internal state of the component is and spit it out so that we can display it. What we don't have yet is, well, any kind of state. I mean, if we take a look over here, sure enough, null is our current state. So we want to initialize this component with some state when it is first constructed. So we're going to create a constructor, and this is going to take props. That's pretty much what they usually call it in React. We're going to call super, passing in the props just to make sure that we don't break anything in the base class. And then what we want to do is we want to set the state equal to an object. And let's just make sure that we see this come through in the browser. And we do, great. So now we have fields for username, for quantity, for colors, and for mailing lists. So why don't we use those as our keys? So we've got username, which I guess can start as a blank string. Quantity probably makes sense to start as 0. Colors is going to start off as a blank array. And then we're going to have mailing list, and that will start off as false. Let's make sure that we're seeing that. Perfect. So now we are effectively initializing the state of the component, and now when we fill in the form fields, we'll be able to update that.
Now it's time to wire up those form fields. I can already tell that there's going to be some opportunities to move responsibility out of the app component and into new subcomponents. Let's start with the name field.
So to start, we want to take the username and wire it up so that when the username field changes, then the internal state's going to change as well. So we need an onChange handler here, and that's going to be some new function that we're adding to this object. Let's call it update field. We'll add that up here. And this is going to be a function that takes an event, and inside of the event, there's going to be a few things. So we know there's a target, event.target, and the target is going to be the actual field that is being changed. And then that's going to have a name, which will tell us which field it is, and it's going to have a value, which will tell us, well, what was the actual value that was changed to. That's going to be handy. And then we pretty much just want to use setState. It takes key value pairs, so I'm going to use this interpolation in order to make the key equal to the name, and the value is going to be the value. Let's see if this is working in the browser. So I put something in here, and sure enough, we see that the username is correctly being updated. Now, it's pretty clear that we have a lot of duplication here that we could probably take care of. The username field and the quantity field, these other fields, they all have the same app field wrapper. They all have pretty much the same kind of label, a lot of similarities. So let's see if we can't extract this username field first out in order to make it independent, and then we'll see if we can dry it up a little bit. So we're going to yank this out, and instead we're going to have an input. We need to create that input, so that's going to be a new class called input. It's going to extend component. We know that it needs a render, and for now we can return what we took. Now, the one piece of this that's not going to work is that right now we're referencing this update field. Well, the input doesn't have an update field. That was something that was on the app. So we need to pass that in through the props. So I can change this to this.props, and we'll just call it onChange. And then down here for input, we can pass in a property called onChange, and this will be this.update field. And so that way that property will be passed through into the input. Let's see if this is still working. Extend needs to be extends. And sure enough, we are still in a working state here. I really like how our new input component is dealing with the wrapper and label code around the input. It takes those responsibilities out of the app component and it makes the code much more legible. Let's see if we can reuse that input behavior for these other input types. So in the same way that we were able to generalize the onChange functionality, we also want to generalize other specifics in this so that we can reuse it. So first off, let's take your username here and generalize this out to this .props. We'll say label. Now I need to pass label in this input here. And we should still see it here. Great. The next piece is, let's see here. So we've got the name, username. So let's change that to a property. Props.name. And we can make that name available here. It's going to be username. And then the ID here is field-username. I already have username, so let's see if we can create a function that takes care of that for us. I'm going to create a new function. I'll call it field ID, and we'll return this props.name, and we'll put field in front of it. And I think this guy needs to be one of these. All right, so that will do that, and now here we'll be able to change this to this field ID. Call that. Similar thing here, and let's see if that's working in the browser. So if we inspect, all right, sure enough. So we see that it has a name of username, an ID, a field username, and that label also has field username as well. So there's only one thing right now that is keeping us from reusing this input class, and that's the fact that right now it's hard-coded to be an input that has a type of text. We know that we're going to want a numeric input, a checkbox input, and a multi-select. So we're going to have to make that configurable somehow. So I think what I want to do is to create a field function here that is going to be something that could be overridden by a subclass. And it's going to have the logic for what this should be. So we're going to return this. And looks like my autocorrect did not help me here. All right, so we're going to have this .field, and in here we are returning all of this, and I think that should all still work. Let's see if this is working in the browser. All right, so that's still working well. Now we can try subclassing this input. So let's start down here. Bring it up. So we're going to create a new class called, let's call it numeric input. This is going to extend on input. And we know that we have field that we need to deal with. And so I'm going to start off with the same stuff we had here because it's going to be pretty close for a numeric field. We know that we want this to have a type of number. Otherwise, we still want the name, we still want the ID, we still want the onChange behavior. So that's all going to stay the same. So let's now go down here and swap this out. So we could take this input and change this to a numeric input. We don't need the type. We do need the name. ID is something that's already being calculated. We're going to want a label. The label's quantity. And we need that onChange. And this is once again going to be this .update field. And since our update field is looking at the name and the value of whatever field called it, this should still work. So we can get rid of all of that. We have the numeric input. Let's take a look in the browser and see what happens. So, okay, so it is a numeric, and as we change this, sure enough, our quantity is changing as well. But there is one problem here. The quantity, it's changing, but it's a string. I think I want my quantity to be an integer, not a string. The text field should give me a string. This numeric field should give me an integer. So that's something that we're going to want to fix. So it looks like the easiest place to make this change is going to be inside of update field, because we have the context of the target and we know whether we're talking to a text input or if we're talking to a numeric input. So that's a good place, I think, to put in some logic here. So if target.type equals text, then we know, well, let's hear, you know what? If it equals number, then we could maybe have this be overridden, and we could just say value equals parse int value 10, and then this next line is still true. Let's see if that works in the browser. So now over here in quantity, I can increase this, and sure enough, now it's an integer. Perfect. Next, I want to jump down and swap out the checkbox that I have here, because that'll be very similar as well. So I think what I want to have is, this would be a checkbox input. And let's see here, the name is going to be mailing list. The label is going to be join our mailing list. That change is going to be the same. And all I really need to have is a type equals checkbox. So I might just copy this whole thing and so make this a checkbox input. It's going to have a type of checkbox. We like the name, we like the ID, we like the onChange. All that looks good. So let's take a look at it here. And we've got this on and off. Well, okay, so good news, bad news. It looks like the field works correctly, but now it's just saying mailing list on. So if I take a look at the element, so it looks like the input, the value is on, but that doesn't tell us whether or not it's checked. I think that's just the default value for a checkbox in React. So rather than looking at the value, we actually need to look at whether or not this thing is checked. So once again, it looks like the update field function may be the easiest place to solve this. We already checked to see if the target type was number, so we could else if target type equals checkbox, and we know that rather than looking at the value, what we really want is target.checked. If we take a look in the browser, now if we move this, all right, so every time we click it, we're seeing true and false. Now the last input that I want to create is for this multi-select. It's got all of these colors in it. It would be great to just pull all of this right out of app, make it its own thing. So I'm going to yank this out. We're going to come up here. We're going to create a new class. I'll call it colors input, since it's going to have all of the colors baked in. And once again, we need to create field. We're going to return all of this. And we need to change a few things. This is going to stay the name. We know we want this to be this.props.name. The ID, once again, going to be this.field ID. And we're going to need to steal this here. And let's format this a little bit better. Let's make it a little bit easier to read. All right, then we've got those options, which should still be fine. So then we need to use the colors input down here. It'll be similar to this. So colors input, the name is going to be colors. Colors used. We don't need any of that stuff anymore. Let's see if it works in the browser. let's see here. So good news, bad news. So it looks like I still have the multi-select, and it's still selecting multiple things, but all it's doing is it's looking at the first of these, and it's not looking at the additional ones that I add. So I had to check the documentation. Turns out that the multi-selects don't really give you an easy way of getting all of the values that have been selected. What you have to do is you have to run over the options, check to see which ones are selected, and then you can kind of create your own array for that. So we can similarly continue this pattern here, else if target.type equals, and maybe this is just a React thing, I'm not sure, but apparently you can look for select multiple. And then I'm going to paste this on in here. You apparently have to use for each. It doesn't actually come with the options. And so you have to do some of these shenanigans. But we're basically going to iterate over all of the options on the target. And for each one, check to see if they're selected. And if it is, we're going to push the value onto this array of values. Let's see if it works inside of the browser. So now I see orange as an array. And sure enough, now I'm getting exactly what I had hoped for.
Oh, hey, what's up?
Look, I'm not angry. I'm just disappointed.
Disappointed by what?
Do you not remember the last episode? Or is it just saying some kind of a blow to the head? Open-close principle. You're breaking the open-close principle.
Yeah, I guess you're right. I mean, every time that I add a new input type, I have to modify the app's behavior, and that code's getting big fast. Well, okay, so I'm going to need to work on some refactoring, and probably rework the classes into a common interface. Whoa, wait! There's more! Sure, the symptom that we see is an open-close violation, but there's something more sinister lurking under the surface. The root of this problem is a violation of the Liskov substitution principle. I have to find a new job. The Liskov substitution principle was originally introduced as strong behavioral typing in a conference keynote given by Barbara Liskov in 1987. It was later fully fleshed out in a paper in 1994. Now, to be frank, the Liskov substitution principle gets a bit of a bad rap. I've heard more than one person suggest that the only reason why it's part of the solid principles is because the SOID principles didn't really have a ring to it. Now, to be fair, it is the most mathematical and esoteric of the principles. Here, just look at the formal definition.
Okay, what have we here? So let bullseye with an arrow in it of X be a property, you know, like real estate. Provable about objects X of type T, which we all know stands for tofu. Then bullseye with an arrow in it of Y should be true, not a liar, for objects Y of type S, which of course means sushi, where sushi is a subtype of tofu. So it's about Japanese food and a submarine with arrows. Makes sense to me.
Well, for the rest of us who lack your keen insights, I'm going to translate this into something that makes a little more sense. Wherever an instance of a base class is used, you should be able to substitute it with an instance of a subclass without breaking anything.
Yeah, well, it makes a little bit more sense. A teeny bit.
It makes a lot more sense. Another way to think about it is that a subclass should never break any contract that the base class has with its users. Let's use this climbing wall that I'm building as an example. Imagine that we want to model the wall and these handholds as classes.
So the wall class has an attach handhold method that takes a handhold. It drills a few holes, adds screws, and attaches the handhold. We would start with a single handhold. How about this one? It's red. It's got a particular shape to it that differentiates it from the others. But the wall doesn't care what color it is or what shape it is. Right now, it only cares about how the handhold is attached. The wall class has a contract that says that a handhold needs to have 2 holes that are spread about 3 inches apart, and it can be attached with 2 screws. Perfect. The handhold class held up to its side of the contract, and the pieces integrated beautifully. You could then imagine that we might subclass this handhold class in order to make new handholds of different shapes and colors. Now, the Liskov substitution principle asserts that these would have to hold up the same contracts that the base class had with its users. Now, thankfully, even though there are different colors and shapes, they still have 2 screw holes that are about 3 inches apart. And so we can still attach them to the wall without making any changes to how the wall works. But what if that wasn't the case? What if green handholds used 1 big screw instead of 2 small screws? Or if blue handholds required glue instead of screws? Or if yellow handholds had to be attached with painter's tape? Now this is getting out of control fast. Every new subclass is breaking the contract that original handhold had with the wall. And now the wall needs all kinds of new processes to attach handholds that it didn't need before. In the code, we can see that the attach handhold method is bloating very quickly, which points to an open-close violation. But see all of the type checking? The type checking is a dead giveaway that what we really are seeing here is a Liskov substitution violation. Now it's clear that each of these handholds in the real world is a handhold. And yet this might be one of these situations where real-world classifications are not particularly useful in the code world. If one of these requires painter's tape and one of these requires glue, then they probably shouldn't inherit from a base class that uses screws. Now once this faulty inheritance is broken, now you're able to reassess. Perhaps you want the wall to have different functionality for attaching a handhold with glue versus tape versus screws. In fact, you might even decide that that's a useful classification in your system for new base classes. And you could subclass those while fully meeting the Liskov substitution principle. Then again, you may decide that really all of these things should use 2 screws. And if they're supposed to be glued, well, maybe you glue them onto 2 screws, and then they can be transparently installed into the wall. And this would meet the Liskov substitution principle.
Look, this is all educational or whatever, but I'm a JavaScript developer. I don't use classes and inheritance. I use other stuff.
Well, that is true. Some JavaScript developers don't use classes or classical inheritance. And there's others who use classes in the context of React or a framework like that, but it doesn't necessarily seem like proper OO just because it's the framework that is handling the object lifecycles, not the developer. So, does that mean the JavaScript developers can just throw out the Liskov substitution principle?
Please say yes. Please say yes. Please say yes.
No, you cannot throw it out. Now, believe it or not, I think that Liskov substitution principle may be more important in dynamically typed languages than in statically typed languages.
What?
Now, hold on. Let me explain myself.
Now, with static languages, we have the compiler and IDEs that are going to largely prevent us from creating subclasses that break the contracts of our base classes. Now, there will always be a few cases that might slip through, but that tooling can go a very long ways. Now, with dynamic languages, it can seem like LSP doesn't apply so long as you avoid using inheritance. No subclasses, no probs, right? Well, let's rework this code in order to not use any classes, and we'll see how it shakes out. So, what changes do you see?
Well, the handhold classes are now just simple data objects, and the attach handhold method is now just a named function. And inside of that function, boy, it's still a mess.
Exactly. We changed the shape of the code a little bit, but that open-close violation is still there, as is the underlying Liskov substitution violation.
Wait a minute. You said it was only a Liskov substitution violation if the calling code used type checking. I don't see any instance of statements in here.
Aha, so I said that explicit type checking was a dead giveaway that there was an LSP violation, but that's not the only criteria. In fact, that's why this principle is so important for dynamic code, is it helps us to be thinking about implicit types.
Huh, implicit types? Ha, now I've heard everything.
Just because there are no classes in the code doesn't mean that there are not types represented. It doesn't really matter what the syntax is. What matters is the abstractions in our mind and the intent of the code. Now, while there is no language structure that relates these handholds to each other, we know in our minds that all of these things are handholds, and that the idea of being a handhold must be meaningful in our code.
Go on.
Sure enough, you can tell by the name of the attach handholds function and the argument that it accepts that it wants something with the implicit type of handhold, even though you can technically pass anything in. So if you acknowledge the existence of these implicit types, then the implications of Liskov's substitution principle play out as usual. There was a contract that was established by that first handhold, and then the handholds that came after it broke that contract, and hijinks ensued.
So let me get this straight. I hate using typed languages, so I use dynamic languages. But now LSP says that I have to worry about types again, but now the types are invisible?
Well, yeah, that's about right. I suspect this is part of the reason why static typing is suddenly making a comeback in the JavaScript community with Flow and with TypeScript. As a rule, explicit beats implicit every time. So what do you think? Did you follow all that? Yeah, I think so. I mean, what looks like an open-close violation here is really a violation of the Liskov substitution principle. The implicit type checking that I'm doing in my code shows me that the contract has been broken by subtypes that don't conform to the base class's behaviors. Yeah, that sounds right. Now get in there and fix it.
Taking another look at this update field function, it's pretty clear that all of this logic doesn't belong here. This logic is determining for the different types how to parse out the value, and that very much belongs in these separate classes. So I think what we want is for each of these classes is to have maybe a function called value, which given a target that gets passed in, it will be able to tell you what the actual value of that target is based on its type. So let's implement that. We'll start up here in the text input. So we're going to have value, which takes a target. And this is easy because we're just going to return target.value. Next, we've got the numeric input. And so this is going to be similar, except we want to do the parse int. And for the checkbox, we know that rather than using target.value, we want to do target.checked. And then finally, for this colors input. You're going to have to come down here and borrow this. All right, so then this should do that logic that we had before of collecting up all of the selected option values. Now that we have value here, what do we do with it? Well, right now the way that we're handling the changes is that for each of these inputs, when there is a change, we're directly taking that change event and sending it on to the onChange that was passed in the props. Now, what I think we need is something in the middle. I think that we need a local onChange that will then also be able to pass the actual value through. So that could look something like this. It's going to take an event, and we want to call this .props to onChange with event, but also with whatever the value is. And that's going to be using the event.target. And now this onChange will be inherited by all of the other classes. So we just need to remove the this.props there. So now onChange, we're going to call our onChange. We do that similarly down here and here and one more time down here. So now they are all going to call the onChanges that are specific to the class. And then we need to update this function because now update field is going to be receiving a value as well, which means that we don't have to get it from the target, and we certainly don't have to do all of this mess. Well, let's see if it works in the browser. Sure enough, that still works. Quantity still works. We've got our colors, and the mailing list is working as well.
The code is live! The code is live? The code is live!
The code is live?
The code is live!
The code is live! It's beautiful! It's so beautiful! Thank you! Thank you!
Well, another day done and another episode complete.
Ha! Well, it's about time. It took you forever to finish this episode.
Now, don't get snippy. We had a lot of good stuff in this episode. We started by exploring the Cynefin framework so that we could understand the impact that complex versus complicated problems would have on our teams.
Yes, once again proving that every force in the universe can be described by a 2x2 grid. Watch out, Pundit Squares, we're coming for you.
We wrote some React code, and we saw how Liskov substitution violations can disguise themselves as open-close violations.
I don't want to alarm you, but I think I see a Facebook lawyer hiding in that bush over there.
And finally, we learned that types and subtypes and interfaces still matter, even in JavaScript, even if we don't have language constructs for them.
Well, I guess it was about time that we put the Java back into JavaScript, am I right?
Well, lucky for you, we're going to be talking much more about interfaces and types in our next episode, the Interface Segregation Principle. You're not going to want to miss it. Hello?
Ah, Mr. Powers!
Yes, want to let you know I've finished the painting that you commissioned. I must admit, when you first asked me to paint a portrait of you, bare-chested, riding a unicorn, I thought it rather foolish, but now that I've seen it with my own eyes, it is majestic.
Whoa, okay. I'll come get it in a minute. Thanks. I need to go run a quick errand. I'll see you next time on Clean Code in the Browser.